In this video, we'll be exploring why sparklers can burn under an atmosphere of carbon dioxide. Considering CO2 is a common fire extinguisher, then why can't it put out a burning sparkler? First, enough sodium bicarbonate was added to cover the bottom of the beaker. The amount added is arbitrary and it's in a large excess. Next, enough 6% vinegar was added to wet all of the sodium bicarbonate. Immediately upon the addition of the vinegar, there'll be a lot of bubbling due to the release of CO2 gas. A watch glass is placed on top to keep the CO2 gas trapped inside. Now, a piece of paper is ignited, and when it's placed inside the beaker, you can see that the flame is immediately extinguished. The beaker effectively contains only CO2 gas, and without oxygen, the combustion of the paper cannot be sustained. So now let's see how sparklers burn under CO2. For a better visual effect, 3 sparklers were used. You'll notice that when it's placed inside the beaker with the CO2, unlike the paper, it continues to burn. However, it lets off significantly less light and much fewer sparks. So now the question is, how is the sparkler able to continue burning under CO2 but the paper was not? The simple answer is that the sparkler has its own oxygen supply. Fireworks often contain an oxidizer, and there are many examples of these. All of them are mostly different types of nitrate or chlorate salts. In the case of the sparklers, the oxidizer that's being used is likely potassium chlorate. In general, the way that these oxidizers work is that when heated, they break down into a salt and oxygen. This internal and localized oxygen supply allows the reaction to occur much more vigorously and violently than it normally would in atmospheric oxygen. This is why nitrate salts are often used in explosives. Without the nitrate salt, the reaction might occur slowly or not even at all. However, with the nitrate salt, the reaction is extremely fast and destructive. Above is an example of the decomposition of potassium chlorate. So once the sparkler is ignited, the potassium chlorate starts to break down and release oxygen, which perpetuates the reaction. So when the sparkler is ignited, it is consuming oxygen from both the air and from the oxidizer, which allows the sparkler to burn as intended. However, when it's placed inside the beaker containing the CO2, it no longer has the oxygen from the air, and the only oxygen supply that it has is from the breakdown of its oxidizer. The sparkler is now burning with an oxygen deficit, and for this reason, it produces much less light and many fewer sparks.